Yeah, so just to conclude Cyrus' talk, we were thinking it would be a good idea to show you a practical implementation of what he discussed. So we've seen that MXNet has a very rich ecosystem. And one thing, one day, let me tell you a story, yeah. One day I was at Amazon. We have this conference called AMLC, where we have like scientists from Amazon coming from all over the world to Seattle and meet, and everybody showcase their work. And what happened was, it's open to everybody, then developers as well. So everybody can really ramp up on machine learning and deep learning. And I forgot to sign up in the morning. I got the email, and in the afternoon they sent an email to say, it's over, it's oversubscribed, nobody else can join. And I was like, well, I really want to go. So I asked around, and they said, the only way you can go is if you have something to demo. You need to be a speaker. And the search workshop, they were asking for last-minute submissions. So I was like, you know what? I always wondered how visual search works. So I submitted like a 5-line proposal. I told them, you know, I'm going to show you a demo of MXNet and visual search. I got the email. They said, yes, accepted. And I was like, OK, now I need to actually build it. And it took me about a day to put that together. Just what I want to tell you here is like, it's so easy, it's so flexible, the API and the model zoo and the tools you have built around MXNet, that you can do a project like that in about a day. So who knows what visual search is? OK, quite a few of you. Yeah, you might have seen that in Pinterest or even on Bing search, Google search. You have this ability to do a query with an image, and you get back a bunch of images which are related. When you do that, you can think you might not just want images. You can actually get products. So if you run an e-commerce website, for example, Amazon, what you can do is, let's say I search for this stuff. What I get back is the list of all the related products. So instead of someone like typing, I want like this specific type of whiteboard that is actually, you know, I want the green and red one, not the blue and yellow one, or you just put a picture. Like you don't need any keywords. It's very explicit. And what's interesting is, for example, here I get a bunch of products related to kittens. Let's say I actually look for this part. I get a bunch of products related to grass. So I think in itself was a cool application. So I did the demo, and I got to attend all the other talks, and I learned a lot. Well, I want to show you, first to tell you a little bit how it works, if you're interested. So how it works is you simply take a pre-trained network. You don't have to train yourself. You just take something from the model zoo, and I'll show you then the code. It's like literally 5 lines, not even 5 lines. It's like 2 lines. You get the model from the model zoo. You remove the last layer, and you get yourself a featureizer. These features, they represent their representation of your image. So then you can just take your entire catalog of images. You pass that through your pre-trained neural network, convolutional neural network, in that case, ResNet 18. And for each image, you get 512 numbers. And these you can index. And then when you have a new picture, like you see here, like this perfume bottle, well, you get a new representation. And the thing you can do is k-nearest neighbor search. So you find the closest matching items inside this feature space, and they're going to have very similar visual properties. So, and you have libraries to do very efficient k-nearest neighbor search, and you can see how like reactive the search is. Actually, here it's not too much because of but usually it's like sub-second, and the actual inference is less than 50 milliseconds. And this model, I deployed it, this entire system deployed it with MXNet model server that we heard before. I put the model inside the Docker container, and I deployed it on AWS Fargate. So I don't even have to manage my own servers. It's running on a serverless system called AWS Fargate, which lets you deploy your containers. So I don't want to show you the code. So we have the data part, like everybody knows that the hardest one, where you download all the data and you process it. And then the actual network part. Where is it? Oops. Yes, so that's how you get your featureizer. That's the kind of code I want to show you. Where is your plus? Yep. Okay. So you can see that that's literally how you get your featureizer. How you it used to be like a fairly complex. You had entire tutorials to get a specific layer in a neural network, and then you use that as your featureizer. Here, I literally say I want ResNet 18 pre-trained, and I want the featureizer part. And in 2 lines, and then the next time you pass data through that, you get 512 numbers, and you do whatever you want with them. And what I did is I indexed them, I did k-nearest neighbor search on it. So that's about it. I just wanted to show you like a cool demo and application of deep learning, and that there's nothing so hard about it. What we want is really, we made a lot of effort on usability and make it accessible to everyone. So check out Gluon, and we're going to, I guess, break now for a few minutes, and then we'll move to the next talk, where I'm going to talk to you about the 3 layers where you can really make big strides in order to make deep learning training and inferencing cheaper, which is code optimization part, which is very often kind of forgotten. People move straight away to adding more hardware. So then we have like the hardware part. And then for inference, we'll see what AWS can offer with the announcement that we heard this morning, elastic inference, and coming up, AWS Inferentia. OK, thank you.